us continue with this page. This page is about the tendency of y as x approaches a, where a is a special value. So of course, when we look at this, we need to know when should we use these techniques. Okay, so we have a table on page 4 which explain when we should use these techniques. So let me write down for you. So first, we need to know we use this technique when we are going to sketch graph involving exponents like x, ex, or graph involving ln. Okay, so we use the tendency of y as x approaches a. So let's see. We look at the note here. A, normally x approaches infinity only, or x approaches negative infinity only, or x approaches a, in which a is a value that contribute to the failure on defining x. Okay, so to understand this, so let us take example. Okay, example, you can see B. If we have y equal to x ln x, we will consider the tendency of y when x approaches positive infinity. Okay, so that means out of these two choices, positive infinity and negative infinity, we choose positive infinity. Okay, the reason is because our ln x is defined when x greater than 0. Okay, so x greater than 0. So because of that, we want to know how is the graph move when x becomes very big. So that's why we consider x approaches infinity, and then we want to see how is the graph. We cannot consider x approaches negative infinity because the x value can never take negative values. Okay, so the other thing is we also consider a special value like 0. So why 0? Because ln x, as you can see here, ln x can take value more than 0. So we want to find out the graph of y equal to x ln x when it is very close to 0. So normally the graph will either go down, which is y approaches negative infinity, or the graph will go up, that is y approaches positive infinity. So we want to determine that. Okay, so let's say for example, I want to sketch this graph, y equal to x ln x. Okay, now let's see what should we do. If we have y equal to x ln x, so we want to sketch this graph. What kind of technique do we need to use here? So I just list down. We need to find out axis, intersections, stationary point, empty space, tendency of y when x approaches a special value. So these are the techniques that we need to consider. Okay, now let's take a look. First, axis intercept. X cannot equal to 0, so don't expect any y-intercept. So no y-intercept. When y equal to 0, then we have x ln x equal to 0. Okay, so of course x cannot equal to 0, then ln x equal to 0. This one is possible where x equal to 1. So this is the X-Intercept. Okay, now the next one, we want to know the stationary point. Okay, so to find out the stationary point, we have to do differentiation. So we have y equal to x ln x. So we have to use product rule. X 1 over x ln x 1. So this is the result of using or applying product rule. So we have 1 plus ln x as our dy dx. So to find stationary point, we let dy dx equal to 0. Then we end up with 1 plus ln x equal to 0. Ln x equal to -1. X equal to e to the power of -1 or 1 over e. Okay, so we find out the y. Y equal to 1 over e ln e -1. Simplify this. You know, this -1 you can move in front, then ln e is 1, so end up with -1 over e. So the stationary point is 1 over e, -1 over e. So we want to find out, or we want to determine whether this point is a maximum or minimum point. So we do second derivative. d2x dx2 equal to 1 over x. Substitute 1 over e inside. Then you get e, which is greater than 0. And because of that, this point is a minimum point. Okay, so the next thing that we need to look for is the empty space. So how to see the empty space for this case? We focus on the ln of the exponent. Okay, so the quick notes here is, if we have ln, you remember x is always greater than 0. So empty space happens at the region where x less than or equal to 0. If you have exponents, for example, if you have ex, so we need to know that ex is always greater than 0. So because of that, the empty space is where ex is less than 0. Okay, now let's see our example here. So our equation is y equal to x ln x. So because of the ln x, right? So we know that x is always greater than 0, and the empty space is hence when x less than or equal to 0. So how is this affect our graph? So imagine that if we have a graph like this, y, x. So we will have graph when x is more than 0. So which is on the right hand side of the y-axis. And on the left hand side of the y-axis, we will have empty space, no graph there, that means. Okay, so let's say I shade this region. So meaning that this region is empty space. Okay, so that is how we apply empty space. Now let's move on. So the next technique that we need to use is the tendency of y when x approaches a. Okay, so I do it here. Tendency of y when x approaches a. Okay, so what value should we consider? First, we consider positive infinity. So why we consider positive infinity? Because our graph go all the way to the right. Okay, so we want to see what happened to the y. So what we can do here is we can just try with calculator. So for example, you key in x ln x. Then after that, you press calculate and you substitute with big values like 1000, for example. When I substitute 1000, I get 6,907. Okay, so I just put it here. When x equal to 1,000, y is 6,908. Okay, so now I substitute with a bigger value, let's say 100,000. When I substitute 100,000, I get y equal to 115129293. Okay, so showing that when x is getting greater and greater, y is getting greater and greater as well. So in general, we can say that when x approaches positive infinity, y approaches positive infinity as well. So that means our graph, you should expect it to keep going up in this particular way. Keep going up. When x is greater, y is greater. So the graph will go up in that way. Now, the other special value that we need to see is the right-hand side. As you know, I shade in green color regions, showing that x cannot enter, the graph cannot enter negative x values. So we want to see what happened to the graph when they are very, very close to 0. Okay, so when x approaches 0, what happened to the y? Okay, so we can just try with calculator. Let's say I try x equal to 0.1. Okay, so when I try x equal to 0.1, I get to know that my y is negative 0.230. Okay, I make it closer. I let x equal to 0.01. Okay, then I get to know that my y is negative 0.046. Now I try even closer. I try 0.00000001. Okay, so when I try x equal to 0.00123456, then I get y equal to negative 1.61 times 10 minus 6. So in other words, we can see the trend. When x is getting closer and closer to 0, y is getting closer and closer to 0 as well, but from the negative side. So what we can do now is we can sketch the graph. Now let's see all the relevant information that we have. I will circle it in green color. So the information that we need to use, this one, and empty space. Of course, we have used it. As you can see, I shade the green color region in the graph. So beside that, we also need to use the X-Intercept, the minimum point. Okay, so now with all this information that we have, let's see how we sketch the graph. So first of all, I'm going to put the minimum point. 1 over e is actually 0.36. So 0.36 minimum point, so it's around here, 1 over e, negative 1 over e. Okay, this is a minimum point. And then we know that from the tendency of y, we know that when x approaches 0, y approaches 0 from the negative side. That means it goes to origin, but it never equal to this point. Okay, as you know, x cannot equal to 0. So it will go there, but never equal. So we put a circle to show this kind of situation. We also have x equal to 1 as the x-intercept. So I should expect the graph to go up and keep going up. So it keep going up because of our result here. When x approaches positive infinity, y approaches positive infinity. So it shows that the graph will keep going up. Okay, so empty space is used here. X-intercept is used, which is here. Minimum point is used, which is here. Tendency of y here, as well as here. Okay, so that is how we use the technique to sketch the graph. So we have done for graph sketching. Now let us continue with the applications. Number 4, tangents and normal. Okay, so you can see tangent is a line that passes through or that touches the curve at one point, let's say point P, with coordinate x1, y1. So this line which touches the curve at one point is known as tangent. So normal is the line that passes through the same point, but it is perpendicular to tangent. Now these are the steps to find the gradient of tangent. Step 1, differentiate the equation of curve. So the equation of curve is y equal to fx. You differentiate it. Step 2, substitute the point P, x1, y1 into dy dx. Then the gradient is known as gradient of tangent. Now B, find equation of tangent. First steps, differentiate the curve. Second step, substitute the point given into the dy dx. Third steps, use the straight lines formula, y minus y1. y1 is the y coordinate of point P, equal to m. m is the gradient of tangent from step 2, x minus x1. So x1 is the x coordinates of point P. So you will get the equation of tangent, which is a straight line. If you want to find gradient of normal, first step, you have to differentiate the equation of the curve. You have y equal to fx, you differentiate it, you get dy dx equal to f prime of x. Step 2, you substitute point P, which has coordinate x1, y1 into dy dx, and you will get the gradient of tangent. Step 3, you find the gradient of normal by using the perpendicular formula, gradient of tangent. So there's a typo error here, the extra a is there, so no a. So gradient of tangent multiplied with gradients of normal equal to -1. So by using this formula, then you can find out the gradient of normal. On the next page, we have equation of normal. So to find the equation of normal, first step, differentiate the curve. Second step, substitute point P into the dy dx. Third step, use the perpendicular formula to find gradient of normal. And step 4, to find the equations of normal, we use formula y minus y1 equal to m x minus x1. Okay, so these are the steps in finding tangent and normal. Okay, now let's see one exam questions on page 37. Number 13. So you're given with y plus x plus 3 equal to 0 as the tangent to the curve y equal to px squared plus qx. This is the curve at x equal to -1. So you have to find the values of p and q. Six marks questions. Okay, so how are we going to do this? First, if we follow the steps to find the equation of tangent, we have to differentiate. Differentiate the curve. Don't differentiate the equation of tangent. Differentiate the curve. So you get 2px plus q. Okay. Then after that, we have to know that the second step is we substitute the x coordinate inside. The x coordinate given is -1. And it is equal to gradient of tangent. Gradient of tangent, you can find it easily by looking at the equation of tangent here. You rearrange it in the form of y equal to mx plus c. Then you will get gradient of tangent. Gradient of tangent is -1. Okay, so you substitute gradient of tangent, which is -1. You substitute inside there. Okay, then you will get -1 equal to -2p plus q. So q equal to 2p minus 1. Okay, so you get the equation. We just hold it first. We call it equation 1. Okay, now beside that, we need to find another equation, and after that we do simultaneous equation. Okay, so what we can do now is let's find out the touching point of the tangent with the curve. So we have x equal to -1 as the information. So we substitute x equal to -1 into the equation of tangent. Then we get y equal to -1 -3, y equal to -2. So the touching point is -1 -2, and we can use this point. We substitute into the curve. So this point into curve. Then we will get another equation so that we can do simultaneous equation afterwards. Okay, then we get -2 equal to p minus q. Okay, then you substitute with equation 1. So this one I call it equation 2. Substitute equation 1 here. Then you will get -2 equal to p minus q. Q is 2p minus 1. So -2 equal to p minus 2p plus 1. So we get minus p plus 1. Then p equal to 3. Okay, so we get the values of p now, which is 3, and q equal to 2, 3 minus 1, then we get 5. Okay, so p is 3 and q is 5. So this is the answer. Let's check first. Question 13. Yes, okay, this is the correct answer. So that is how we apply our information, our knowledge in solving the questions involving tangent. Okay, now let's continue with number 5, rate of change. So rate of change means how fast a variable change. So for example, you have rate of change with respect to time t. So that means you will have dt at the bottom. For example, dy dt is the rate of change of y with respect to time t. dv dt is the rate of change of volume with respect to time t. So you will see that the variable on top will be the rate of change of that variable, and the dt at the bottom is where we just call it with respect to time. Okay, so for example, if you have rate of change of area with respect to time, so you should expect the derivative to be written as dA dt. So normally when you solve question involving rate of change, we have to use chain rule. For example, you want to find the rate of change of y, we may use dy dx multiplied with dx dt. Of course, dx dt is the rate of change of x, and this value is given. So for example, these are the general steps. Identify the given rate of change. That means the question will give you the rate of change. So for example, they give you the dr dt, rate of change of radius. Then you just write 2 cm per second. Step 2, identify the required rates of change along with the given parameter. So that means you have to recognize, you have to find out what kind of rate of change is asked. Okay, you write it down, then at the same time they also give you the values of r. The value of r is going to be used after you do differentiations. Okay, we will see how to use this r equal to 5 later. So step 3, use chain rule to relate the rates of change. So you have given with a rate of change, and you need to find this rate of change. So you need to relate these two by using chain rule. We put the question on the left, dv dt is the questions. We put the dr dt, the given information, on the right, and then you need to use common sense to get another derivative. So what kind of common sense are we going to use? We need to balance the chain rule. So as you can see, we have dv on the left, so we put dv on the right. We have dr on top, so we put dr at the bottom. Okay, so we balance the equation by having dv dr as our extra derivative. Now step 4, identify your extra derivative, that is dv dr for our case here. So you have to use geometry formula normally to find v in terms of r. So it depends on what kind of shapes are we discussing in the questions. So for example, let's say they are talking about the volume of sphere. So v in terms of r, the equation is going to be v equal to 4 over 3 pi r cubed. Then you differentiate dv dr equal to 4 pi r square. You get dv dr. After differentiation, you can substitute the parameter 5 over here. So as you can see, let's substitute 5 into the r. Okay, now step 5, substitute your extra derivative found to your chain rule in step 3. So we put dv dr at the back, we substitute 5 inside. We also substitute the dr dt is 2, we substitute in front. So we substitute, we count, then we get the dv dt. Okay, so these are the steps. Now note, if you have rates of increase, put positive. If you have rates of decrease, put negative. Okay, so I have to remember this also. Okay, now let's see one example on rates of change. So for example, let's look at our question on page 30. Okay, I do it here, page 30. Question 1 from checkpoint 8.11. Okay, so the question sounds like this. A cuboid has a square base of side x. Okay, so now I draw out a square base at the bottom. Then like this. Okay, so we have a square base, so we should expect 4 of these to be same length, x cm. Now we continue the questions. Besides square base, they also give us the height. The height of the cuboid is half times the length of the side of its base. So we should expect the height to be half x. If x increases at the rate of 0.02 cm per second, so they give us the x dt, 0.02. Find the rate of change of the volume of the cuboid. That means find dv dt when its total surface area is 1600 cm squared. Okay, so now what we need to do is we have to use chain rule. So we use chain rule to relate the derivative. What they ask, we put on the left. Given information, put on the right. then we have to balance this equation by multiplying with dv over dx. Now dv over dx is known as the extra derivative. So because of that, we have to find out an equation that relates v and x. So since this is a cuboid, so we can see that we should take x multiplied with x to get the square base, multiply with half x to get the height. So v equal to half x cubed. dv dx equal to 3 over 2 x squared. So of course we can substitute the x with values, but the thing is we don't know what kind of x value are we going to take, and because of that we have to make use of the total surface area given, the 1600, to find x. If you look at the cuboid given, so we have to know that our surface include the bottom surface, which is x squared, the top surface, which is also x squared, the surface on the left and right, which is half x squared. This is surface on the left, right, front and back. Okay, so we have left, right, front, back equal to 1600. Okay, now we have to add up everything and find x. So we have 4x squared equal to 1600, x squared equal to 400, x equal to 20. So we can substitute our x value into the dv dx here. So dv dx equal to 3 over 2, 20 squared. 3 over 2 times 20 squared, so we get 600. Okay, so dv dx equal to 600. And we substitute this into our chain rule. dx dt is given 0.02, dv dx is 600. We multiply and we will get dv dt, which is 12 cm cubed per second. Okay, so that is how we do the question for rates of change. Now on this page you have optimization problems, that means maximum problem, maximization problems, or minimizations problems. And now let's look at the general steps to do all this. So first, step 1, express the variable that needs to be optimized, maximized or minimized in the other variable. So let's say for example the question said find the maximum area. Then you have to form the equation of area in x, for example. Then you differentiate, then you let it equal to 0, then you solve to find x, then you substitute this x value back to this original equation, then the area that you get will be the maximum area. Okay, so of course step 1, where you need to find the equation. If you can't remember the formula of geometry, we have the revision over here. So where you can just use the information here. We have the formula to find the volume of cylinder, curved surface area of cylinder, total surface area of the cylinder. We have the volume of cone, curved surface area of the cone, total surface area of the cone. We have volume of sphere, surface area of sphere. We have volume of pyramid, volume of prism, and then we have area of trapeziums. Okay, so now let's see one example involving optimization problems. Okay, let's say I use the question on page 11. Okay, so on page 11, okay, so the question, a piece of wire of length 8 cm is cut into two pieces, one of length x cm, the other of length 8 minus x cm. Okay, so x and 8 minus x. The piece of length x cm is bent to form a circle with circumference x cm. The other piece is bent to form a square with perimeter 8 minus x. Okay, then show that as x varies, the sum of the areas enclosed by these two pieces of wire is a minimum when the radius of the circle is 4 over 4 plus pi. Okay, so we need to show sum of area is minimum when r equal to r of the circle. R of the circle is 4 over 4 plus pi cm. This is a 6-mark question. Okay, now since the question is talking about the minimum of the sum of area, so we have to form an equation involving the sum of area. Okay, so let's say A1 is the area of the circle. So we know that area of circle is pi r square. Okay, pi r square. We know that area 2, let's say area 2 is the square. So we know that area 2, to find it, it's just base times length. Okay, so since we have the parameter of 8 minus x, so we should expect each side to be 8 minus x over 4. And the area is hence 8 minus x over 4 square. Okay, now for the small circle just now, we know that the circumference is x. Okay, 2 pi r equal to x. So r equal to x over 2 pi. So we replace the r with x over 2 pi, then we square it. Okay, then we simplify the equations. X squared over 4 pi plus 8 minus x squared over 16. And we differentiate dA, dx. So where we get 2x, simplify, differentiate again, 2, 8 minus x, minus 1, 16. So the dx is equal to 0. Okay, so we can solve this equation and find x. So I gather up the x term, factorize the x, then I get x equal to 16 pi over 8 plus 2 pi. Okay, so what we want to show is the radius. So we know that radius is x over 2 pi. and we substitute our results into the numerator. Divide by 2 pi. So we need to simplify this. So first of all, I divide by 2 for everything here. Divide by, okay, divide by 2. Then I will get 8 pi over 4 plus pi divided by 2 pi. So 8 pi divided by 2 pi, I will get 4. Okay, then we managed to show what they asked. Okay, so that is how we handle maximization or minimization problem. Okay, so we have done the theory part. So what we have after that is questions. We have plenty of questions. Okay, so we also have extra exercise from here. So this extra exercise is about the way to sketch the y-square graph. Okay, so y-square graph, first you need to know some properties for y-square graph. So y-square graph, I write the properties at the side here. Symmetry about x-axis. Okay, that is one of the important properties. You know, y squared equal to fx is same with y equal to plus minus square roots of fx. Okay, so because of that, we should expect when you have y equal to fx, you want to change it to y square graph, so the coordinates will become like this. Okay, so the x remain, but the y become plus minus square root of y. Okay, so 1, 2, okay, what else? Y square graph, the fx is always greater than or equal to 0. So cannot less than 0. Cannot less than 0. Huh? Cannot less than 0, that means if you have y equal to fx, graph y equal to fx which less than 0, which means below x-axis, will disappear in y squared equal to fx graph. Okay, so number 4, we also have special values, like, you know, our coordinate change in this way. Okay, so if you have y coordinate which is 0, after you square root it is still 0. So we call this fixed points. So if you have y coordinate 1, then after you square root it is still 1. It's plus minus 1. Okay, so fixed points also. But if you have y coordinate in between 0 and 1, then basically you square root any value smaller than in between 0 and 1. So at the end, they will get a greater value, greater y value. For example, imagine if your y is 0.5, after you square root, you will get plus minus 0.5. Okay, so example, 0.5. After you square root, you will get x plus minus 0.7. You can see it's getting greater. Okay, it's getting greater. So 0.5, after you square root, it becomes 0.7. The value is getting greater. Okay, so now if you have coordinates for y that is greater than 1, then when it comes to the y square graph, you will have a smaller y. For example, if you have x2, after you square, then it will, after you square root, then you will get plus minus 1.4, so which is a smaller value. Okay, so now let's see how we apply all this information into graph sketching. So let's say the first one. Okay, so first we need to know the points on y equal to 0 will remain in our y square graph. Let's say y equal to 1 is just somewhere here. Y equal to 1. Okay, the point on y equal to 1 will remain there. Okay, then in between 0 and 1, the graph is greater. More than 1, the graph is smaller. Likewise, it happens to this side. Then symmetry about x-axis. Graph below x-axis will disappear. So graph below x-axis are the graph here, it will disappear. So at the end, the red graph here is the y square equal to x square minus 9. Okay, now let's see again this example. I know 32 over 27 is 1 point something, so y equal to 1 is a point over here. Y equal to 1. So the points on this point, on y equal to 1, the points remain. The points at 0, y equal to 0, the points remain. In between 0 and 1, the graph is greater. More than 1, the graph is smaller. In between 0 and 1, greater. More than 1, smaller. When y is less than 0, so we have to know that the graph will disappear for this part, y less than 0. And the other thing is symmetry. Okay, so we make the graph symmetry, and we get the graph of y square in red color. Now we look at the next one over here, this one. So we know y equal to 1 is just somewhere here. Y equal to 1. So the point on y equal to 0, y equal to 1, this point will remain. So less than, in between 0 and 1, the graph is greater. When the graph where y greater than 1, the graph is smaller. Graph below y-axis disappear. And at the end, symmetry about x-axis. Okay, so we get this. If you have y coordinate 4, so you should expect square root to become plus minus 2. Number 4, y equal to 0, the graph remain there. Y equal to 1, no graph. In between 0 and 1, the graph is greater. More than 1, the graph is smaller. Symmetry about x-axis. Okay, the red one is the y square graph. Okay, now let's move on. Answer question from textbook. Answer question from textbook. past year questions.